The Webb looks so far out that it's capturing light that's been travelling for over 13 billion years. But the universe has been expanding, and so the light has been stretching. And so for the most distant galaxies, we're looking back in time almost to the Big Bang.
The James Webb Space Telescope has made a startling finding using its advanced camera. It has detected an object of tremendous age and magnitude that could jeopardize the universe. What exactly did the telescope observe, and why is it causing apprehension? The most troubling aspect is that the object's origins are still unknown. Join us as we explore the unsettling discovery made by the James Webb Telescope, prompting concerns about the destiny of the universe. The unexpected discovery. The James Webb Telescope has just spotted 6 huge galaxies that were around 500 million to 700 million years before the Big Bang. During the exploration, scientists were only expecting to find small new galaxies, but these were way bigger than they imagined. Scientists also found something super crucial about these galaxies that was vital. They're as surprisingly old as our own Milky Way galaxy, which is a significant 13 billion years old. The stars inside these galaxies are way bigger than our sun, billions of times bigger, which is so fascinating. One of them might even be 100 billion times heavier than our sun. To put that in perspective, our Milky Way has stars that are about 60 billion times heavier than our sun. These extremely huge galaxies, which scientists have nicknamed universe breakers, are causing a major stir. They're like nothing we've seen before. They're so different from what we thought early galaxies looked like. Before, we used to think galaxies started small, like clouds of stars and dust, and grew over time. But these universe breakers are showing us that's not always the case. When researchers got their hands on the data and super detailed pictures from the James Webb Telescope in July 2022, they were blown away. They couldn't believe what they were seeing. These galaxies were like bright spots of light in the darkness of space. It was so surprising that scientists had to double-check their findings. The light from these galaxies traveled a long way to reach us, more than 13.4 billion years. It's like getting a glimpse into the past. Just like when the Hubble Space Telescope first started sending back pictures, James Webb's initial images showed lots of possible galaxies. By using different techniques to analyze light in different ways, scientists can learn all sorts of interesting qualities about these galaxies, like what they're made of, how big they are, and how far away they are from Earth. This amazing discovery wasn't even something scientists were expecting to find with the James Webb Telescope. It's like a bonus surprise. However, through critical observations using something called spectroscopy, astronomers were able to confirm that 4 of these objects were indeed galaxies. Spectroscopy is a fancy way of breaking down light into its different colors, kind of like using a prism to make a rainbow. By studying these colors, astronomers can figure out how far away the galaxies are. Some wonder how they can do that. It's all about something called redshift. As the universe expands, things move away from us, and their light gets stretched out, making it look redder. This is called the Doppler effect. By measuring this redshift, astronomers can figure out how far away something is. There's a doubt, though, that some of the comets the telescope found might not be galaxies at all. There could be hidden supermassive black holes out there, lurking in the depths of space. And here's the fascinating part. Scientists now think there might be way more stars in the universe than they thought before, like up to 100 times more. Using the super-powerful James Webb Space Telescope, a team of astronomers from all over the world made an amazing discovery. These galaxies take us way back in time, to when the universe was just a tiny minor compared to what it is now, about 400 million years after the Big Bang. These discoveries focused on 4 galaxies with really high redshifts, meaning they're super far away. The Hubble Space Telescope had seen 2 of these galaxies before, but the JWST confirmed them and found even more galaxies hiding in the depths of space. It's like discovering hidden treasures in the night sky. The JWST has a special power too. It can see things that our eyes can't see, using something called infrared light. It can even pick up the faint glow from ancient stars and galaxies that have been around for ages. So it's like the JWST is taking us on a time travel adventure, showing us what the universe looked like way back in time. The limitations and challenges to the edge. Recently, it made a big announcement about what's at the edge of what we can see in space. Regarding this edge, it's important to understand something called the observable universe. This is everything we can see and study with our telescopes, from Earth or from space. It includes stars, galaxies, and other space stuff that's within our reach. But the thing is, the observable universe is just a tiny part of the whole universe. We don't know exactly how big or what shape the whole universe is, but we think the observable part is about 93 billion light-years across. That's a long distance. So the James Webb Telescope is helping us explore this huge expanse of space, giving us a glimpse of what's out there at the very edge of our view. It's like shining a light on a part of space we've never seen before. About 13.8 billion years ago, there was a huge explosion that started everything we know as the universe. This explosion made the universe expand fast, and it's still getting bigger all the time. This expansion is happening quickly because of mysterious things like dark energy. As the universe expanded, tiny bits of matter started sticking together because of gravity. This created amazing things like stars, galaxies, and eventually planets like Earth. Over a super long time, these cosmic things got bigger and more complex, creating the incredible variety we see in the universe today. Even though the universe is really huge, most of it is empty space. Even then, the nearest star would still be really far away, like the distance between two soccer fields. And that's just in our Milky Way galaxy, which is one of billions in the observable universe. There are two reasons why we can't see the whole universe. First, light takes time to travel through space. So when we look at faraway things, we're actually seeing them as they were in the past. The farther away something is, the longer it takes for its light to reach us. Second, the universe itself is expanding, like a balloon getting bigger. This makes distant things move away from us, so some things might be too far for us to see. Galaxies are moving away from each other because space itself is stretching out. This stretching makes the light from faraway objects look redder, which is called redshift. Eventually, some things will move so far away that we won't be able to see them anymore. That's why we haven't seen the whole universe yet. There are three main theories about what's beyond what we can see. One theory says the universe goes on forever without an end. Another theory suggests the universe is finite, but doesn't have a clear edge, kind of like a giant ball, where if you keep going, you'll end up where you started. The third theory, called the multiverse theory, says our universe is just one of many, like a bunch of parallel universes with their own rules. Scientists have been wondering for a long time what's way out there at the very edge of space. It's like a big mystery that's been around for centuries, making people curious. This telescope, with its cutting-edge technology, can peer into the depths of the universe, uncovering ancient, distant, or faint objects that were previously beyond the reach of the Hubble Space Telescope. The James Webb Space Telescope is helping to solve this mystery. The outstanding James Webb Telescope. Launched on December 25, 2021, aboard an Ariane 5 rocket from French Guyana.
10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top.
And
Allumage
liftoff.
UAP, décollage.
Decollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
The JWST reached its destination near the Sun-Earth L2 Lagrange point in January 2022. This awesome technology, about 1.5 million kilometers away from Earth, provides an ideal viewpoint for its observations. Its first mind-blowing image was shared with the world on July 11, 2022.
Every image is a new discovery, and each will give humanity a view of the universe that we've never seen before.
Named in honor of James E. Webb, the former NASA administrator, this telescope boasts an impressive primary mirror comprising 18 hexagonal segments made of gold-plated beryllium. Together, they form an awesome 6.5-meter mirror, dwarfing the Hubble's 2.4-meter mirror. With its incredible light-collecting capability, the JWST has about 6 times the observation power of its predecessor. This massive mirror is crucial for capturing faint and distant objects across the universe. Its remarkable feature is that it uses a special light called near-infrared light instead of regular visible light. This helps it see things clearly. It can even detect faint signals from really far away. With its special tools, the JWST can also help solve mysteries like why some stars get dim sometimes. Plus, it can check if exoplanets have methane in their air, which could be a sign of life. Of course, achieving such goals requires some serious engineering. To enhance its longevity, the JWST must be kept super chilled, below 50 Kelvin, to prevent its own infrared emissions from interfering with its observations. That's where its 5-layer sunshield comes in, shielding it from the sun's warmth. The JWST may be smaller in mass compared to the Hubble, but it performs incredibly well. The James Webb Space Telescope was created primarily to carry out 4 main jobs. The first is its ability to trace comets as far back as the very first stars. It wants to see the light from the very galaxies that formed after the Big Bang. The second is to study galaxies and understand how galaxies like our Milky Way formed and changed over time. The third is being able to explore stars and planets. The JWST looks at the places where stars and planets start their lives. The fourth is being able to have a glimpse or send across some information on other worlds. It searches for signs of life on planets outside our solar system, called exoplanets. It can also detect orange and red visible light, as well as delve into the mid-infrared region, depending on the instrument in use. And here's where it surpasses others. The JWST can spot objects up to 100 times fainter than the Hubble can, allowing it to peer back much further in time. It can reach back to redshift Z20, which corresponds to about 180 million years after the Big Bang. To put that into perspective, this means it can observe objects from a cosmic era when the earliest stars were just beginning to form. In comparison, the Hubble is limited to observing objects from much later in cosmic history, with its reach extending back to redshift Z11.1. With its unparalleled capabilities, the JWST is poised to revolutionize our understanding of the universe, unlocking secrets from the dawn of time itself. Ground-based telescopes have to contend with Earth's atmosphere, which can be a real pain, especially in the infrared spectrum. The atmosphere is like a thick fog in many infrared bands, making it tough for telescopes to see clearly. And even when the atmosphere is relatively clear, there's another problem. Many of the same chemicals that astronomers want to study in space, like water, carbon dioxide, and methane, also exist right here on Earth, which can be complicated. On the other hand, the Hubble can avoid atmospheric interference, but it has its own set of challenges. The Hubble's mirrors aren't cool enough to effectively study certain infrared bands. They're kept at a toasty 15 degrees Celsius, which means they emit infrared radiation themselves, interfering with observations. Unlike ground-based telescopes and even the Hubble, the JWST is specially designed to overcome these hurdles. It can peer into the depths of space with ease, even observing objects in our own solar system like Mars, Jupiter, and beyond. Plus, it's got the sensitivity to detect virtually all known Kuiper Belt objects. Talk about impressive. It can quickly shift its gaze to observe sudden cosmic events like supernovae or gamma-ray bursts, making it the ultimate cosmic detective. With its unparalleled capabilities, the JWST is poised to unlock the secrets of the universe like never before. The James Webb Space Telescope is an amazing tool that helps us explore the mysteries of the universe. It's a wonderful telescope that lets us see really far back in time and discover things we never knew existed in the early days of space. With its fancy abilities, the JWST has let scientists look way back to when the universe was just starting out, leading to their unexpected finding. In a recent study, the JWST images showed even more distant galaxies than before. Their redshifts were measured to be 13.20 and 12.63, indicating that they are even farther away. A redshift of 13.20 means we're looking back to a time roughly 13.5 billion years ago. The JWST is also part of an ambitious program called Jades, which stands for the JWST Advanced Deep Extragalactic Survey. This program aims to give us an incredibly detailed look into the early universe. Back in 2015, a bunch of smart folks from different countries got together and proposed this project. They formed a team called Jades, which includes over 80 astronomers and scientists from 10 different countries. The Jades team spent over 10 days studying a small part of the sky, including a spot called the Hubble Ultra Deep Field. This area has been studied by astronomers for over 20 years using big telescopes. The Jades team used special instruments to collect light from about 250 faint galaxies over 3 days. This helped them learn more about the gas and stars inside these galaxies and figure out their redshifts. By studying these galaxies, astronomers can learn about how they formed and changed over time, even if we don't know exactly how they started out. Studying galaxies can be tricky, but it's super important for understanding the history and evolution of the universe. Understanding the early generations of stars is important because they have a big impact on the future of galaxies. Right now is an exciting time because the James Webb Space Telescope is helping to answer lots of questions about galaxies. NASA's Deep Space Observatory Telescope, the JWST, is changing the way we understand the universe and uncovering all sorts of new things. It's like finding a hidden treasure chest full of discoveries. Launched in December 2021, the JWST is expected to keep working for about 2 decades. It's like going on a big adventure into space, and it's even more advanced than the Hubble Space Telescope, which came before it. When the JWST first started taking pictures in mid-July, everyone was amazed at what it showed us about the universe. It's like getting a super clear view of things that are far away. Soon after it went online in late June 2022, the JWST started revealing thousands of galaxies we didn't even know existed. That's not all. It can also study things like exoplanets, planets outside our solar system, and baby stars, helping us learn more about what they're made of and how they move through space. It's like shining a bright light on the mysteries of the cosmos. It's helping us figure out what these planets are made of and if they might be able to support life. But that's not all. The JWST might have found the oldest black hole ever seen. This supermassive black hole is a whopping 9 million times heavier than our Sun. It's chilling at the center of a young galaxy that formed just 570 million years after the universe was born. The JWST's super powerful camera can look back in time to see what things were like in the early days of the universe. This big discovery gives us a peek into what was happening during the cosmic dawn, when lots of black holes were growing after the Big Bang. But even with this cool find, there's still a lot we don't know about these mysterious cosmic entities. Some of them shoot out light that we can see with telescopes, and they're called active galactic nuclei, supermassive black holes, or quasars. They're way bigger and brighter than regular stars, lighting up the universe with their intense bursts of energy. As scientists keep exploring the universe, they're able to see light from even farther away, giving us a glimpse into the early days of everything. The JWST uses special tools to scan the sky and search for more secrets hidden in the vastness of space. It's like being detectives, uncovering clues about the universe's past. When studying black holes, the James Webb Space Telescope uses special tools called spectrographs. These tools break down the light coming from the black hole into different frequencies, which scientists can then analyze. During their investigations, scientists made a really important discovery. They found faint traces of radiation coming from the hot material surrounding the black hole. By closely looking at these faint glimmers from the universe's early days, they noticed something unexpected, a surge in certain frequencies within the light. This gave them valuable insights into how cosmic processes were working back then. Even though scientists have found a lot of black holes, there are still some mysteries. They're still on the hunt for younger black holes, called primordial black holes, which might have formed right after the Big Bang or even earlier. But so far, they haven't found any of these elusive objects. There are a couple of theories about why there are so many black holes in the universe today. One idea is that they're leftovers from really massive stars that formed much faster than the stars we see nowadays. Another theory suggests that dense clouds of gas collapsed suddenly, creating these mysterious black holes in the fabric of space and time. One more likely scenario involves something called a population 3 star. These hypothetical stars would have popped up about 200 million years after the Big Bang and would have been made mostly of hydrogen and helium. When these stars exploded, they could have left behind black holes that grew bigger by gobbling up more and more matter. Scientists are working with a team to study the light from galaxies far away, hoping to uncover more clues about how these puzzling black holes formed. At the heart of our galaxy, scientists have been studying the early days of the universe and recently observed something remarkable: the birth of a protocluster made up of 7 galaxies interacting with each other. This discovery was made using the Hubble Space Telescope and is considered the most distant galaxy cluster ever found by researchers. Simulations suggest that this protocluster will eventually evolve into one of the oldest and largest galaxy clusters we know of, weighing nearly 100 times more than our own Milky Way galaxy. While the Hubble Space Telescope initially spotted these galaxies, it couldn't precisely measure the distances between them due to its limitations. Imagine looking down from high above Los Angeles and seeing cities like Phoenix, Dallas, and Atlanta, but not knowing the exact distances between them. However, thanks to the James Webb Space Telescope, we now have a clearer understanding. These types of galaxy clusters are extremely rare and challenging to find, making this discovery even more significant. Although it's improbable that the JWST will stumble upon another unique system like this, the upcoming Nancy Grace Roman Space Telescope, set to launch in early 2027, will greatly improve our ability to identify galaxy clusters in the early universe. Its advanced survey capabilities will surpass those of the JWST by over 100 times. Looking back at the discoveries made by the JWST in the 1990s, astronomers made groundbreaking findings about exoplanets, thanks to the capabilities of this groundbreaking telescope. This composite image showcases both the optical and infrared views of the galaxy, offering a more detailed understanding of its characteristics. As part of an international effort, these 3 photographs serve as a testament to the collaborative nature of scientific exploration. Featured in a documentary film, astronomers were able to analyze images captured by the James Webb Space Telescope side by side, helping them identify regions where stars are currently forming. This process also allowed for precise calculations of the masses and ages of star clusters. Additionally, studies conducted with the JWST have provided valuable insights into the characteristics of tiny dust particles moving through the vast expanse of interstellar space. One striking image captured by the JWST is that of a distant Wolf-Rayet star, known as WR140, which displayed a unique diffraction pattern. This star is surrounded by a peculiar arrangement of concentric rings, giving it an unusual boxy shape. Surprisingly, these ring formations are not imaging artifacts, but actual features of the star itself. WR140 is nearing the end of its life, having already released a significant amount of hydrogen into space. The interaction between WR140 and its smaller companion star shapes a cloud of dust into the distinctive ring patterns observed. In the constellation Virgo, the JWST has extensively studied an exoplanet named WASP-39b, located a staggering 700 light-years away from Earth. This exoplanet is a scorching gas giant similar in size to Saturn, orbiting its host star at an incredibly close distance, roughly 8 times nearer than Mercury is to the Sun. Ultimately, the JWST was designed to explore the farthest reaches of the universe, and researchers have confirmed its success in doing so. The dream of a powerful infrared space telescope has been brewing for decades. In the United States, plans for the Space Infrared Telescope Facility, later known as the Spitzer Space Telescope, were already in motion during the development of the Space Shuttle. Astronomers recognized the immense potential of infrared astronomy early on, especially since space observatories are immune to the radical interference of Earth's atmosphere. It's like opening a whole new window to the universe. The telescope's heat can overwhelm its detectors, rendering it useless. Thankfully, clever engineering can overcome this obstacle. One method involves housing the critical instruments in a dewar filled with a super-chilled substance like liquid helium. But this coolant gradually vaporizes over time, limiting the lifespan of the instrument to just a few months or years at most. Another approach is to design the spacecraft itself to enable near-infrared observations without the need for external coolant. This was the case with missions like the Spitzer Space Telescope and the Wide-Field Infrared Survey Explorer, which soldiered on at reduced capacity after their coolant ran out. And then there's Hubble's near-infrared camera and multi-object spectrometer, which initially relied on a block of nitrogen ice for cooling. But during a servicing mission, astronauts swapped it out with a cryo-cooler that worked continuously, extending its lifespan. Now enter the James Webb Space Telescope, the pinnacle of infrared observation. Unlike its predecessors, the JWST is engineered to cool itself without the need for a dewar, using a clever combination of sun shields and radiators. Plus, its mid-infrared instrument even boasts an additional cryo-cooler for optimal performance. With these innovative solutions, infrared telescopes are poised to reveal the hidden wonders of the universe like never before. The quality of the James Webb Telescope cannot be limited. Just as space is vast and holds a lot of secrets, the telescope serves as a means to unravel the secrets the cosmos has been hiding. As it keeps exploring, it's bound to uncover even more mind-blowing discoveries, inspiring us all to keep reaching for the stars and expanding our understanding of the cosmos. Thank you for watching. Comment to share what you think in the comment section below. Remember to like and subscribe to see more videos.